answer right now if you want. Part B. Oh, sorry, it's -2. Don't tell me the answer right now, even if you do one. Okay? And we have. I'm going to start working on it. Start thinking. X plus 2 left. C is the overall limit. So we have two. We have a right and a left-hand limit, and we have the overall limit is the last question. No pictures this time. We're not going to find any x-intercepts or anything like that. I'm going to work with the way I just did it a second ago.
You can't draw any pictures.
Say again?
You can't draw any pictures.
You can, if that helps you, you know. But you should really try to analyze the way we just did. All right, so this one here, you're approaching -2 from the right of -2. Okay? So are these x values negative or positive? They're negative, because you're just to the right of -2, so it's still negative. Are they as negative as -2?
No.
Nope, they're not as negative as -2. So what's the importance of that? Is how it influences this factor here, right? Because this is heading towards -2. That's pretty clear, right? That is x. If x is heading towards -2, then this x is heading towards -2, right? This one as well, heading towards -2, which means the top is heading towards a negative. Negative and a negative are going to make more negative, right? So now the question is on the sign of this piece. I hear positive. Everybody agree? The sign of this factor for this limit is always positive, because I am just to the right of -2. So if I add 2 to something to the right of -2, it's always going to make the positive will overpower those numbers, whatever they are, right? As long as it's to the right of -2. Make sense?
Wait, say it one more time.
This x right here is never as negative as -2, because it's always to the right of -2.
Yeah.
It's not quite to -2. So if I add 2 to that, that is going to make it always a very small positive number.
Okay.
Sure?
Yeah, okay, I see.
I know you know it's supposed to make sense, but it's hard to think about it sometimes. Oh, it's not quite as negative as this. You know, it's hard to think like that, right? Think about your number line. Here's -2. You're floating around here somewhere, right? So now you add 2 to that. So 1, 2. You're going to be a very small positive number. Does that make sense? And that's all we're saying with this.
Okay.
So this factor is now going to be positive. So now I have a negative, and a positive inside this ratio. So therefore, it's going to be what sign? Positive. Positive, right? Now, this is heading towards non-zero. This is heading towards non-zero. Non-zero times 0, 0. So therefore, positive infinity, right?
Because there's a negative at the bottom?
Yeah.
On the x?
Yeah.
Okay.
That guy's always negative, right?
All right.
He's always negative.
Yeah.
And this is always negative. This is always positive. Negative, negative, positive. Just like multiplication, division, same thing, right? We've got an even number of negatives, things positive, right? And it's towards infinity. Why towards infinity? Because the top, although it's negative, it is always, well, I guess that makes it clear. It's always negative. It's certainly non-zero. Zero is never negative, right? Down here, this is heading towards 0, right? This product is heading towards 0, right? Something really close to -2 and something really close to 0, that product is heading towards 0, right? So we've got a non-zero to 0 case. That's an infinity. Which infinity? Count up the number of signs you have. I have 2 negatives, so it's positive. Carter?
Yeah.
Knew that. Making good sense? That's solid thinking, right?
So much.
There's no number pushing here. This is just good old-fashioned thinking,
Really?
right?
So much.
And that's why it sits so well in your minds. It's just thinking. No stupid number game, right? All right, no stupid algebras. Now, same game. Approaching from the left. What's going to change? Nothing will change about this. Nothing will change about this. The only thing that changes is this one, correct? This is still negative. It's always going to be negative. This is still negative. This little guy here, right? It's always negative. Now this one, all the x's are more negative than to the left of -2. So all the x's we're considering are more negative, not by much, but they are more negative than -2. So when I add 2 to that, I'm left with a negative quantity, right? Just take negative 3 for negative 3 plus 2 is negative. Negative 2.5 plus 2 is negative. Negative 2.01 plus 2 is negative 0.01. It's always negative, right?
So it's
I got 3 negatives.
3 negatives make it an odd negative.
Let's base negative.
It's negative.
So negative infinity?
Negative infinity. That's right.
Because
Now remember, it's only an infinity because this part's heading towards 0, right?
Yeah.
Don't start applying this willy-nilly to every single problem on the face of the planet. Right? You got to make sure that the bottom's heading towards 0. Otherwise, there's no infinity to write here. Okay? Okay? Now the last one.
Okay.
it does not.
So top part's positive, right?
Now remember, this is a D and E. And this is a D and E. I'm just able to tell you the direction it's heading. That's all. These limits do not exist, right? Okay? So then certainly this last one's a D and E as well. But can you tell me where the overall limit is heading? Is that possible in this case? No. Because from the right, we're heading towards positive, heading from the left, right, right. Negative 2? Negative 2. What direction is this going? I don't know. It's going up one way, it's going down the other way. You can't tell me anything. So down here, D and E is all you can write. You cannot even tell me a direction. Okay? Yep.
Doesn't the left and the right have to equal each other?
Do they have to equal? Is that what you said?
Yeah.
That's correct. That's right. That's what we said last time, right? That's right. Okay, any questions about that example? Oh, there's a great example. No, you sure? $27. Limit as x approaches 1 from the right. That's all it says. X squared minus 5x plus 6, x minus 1. Okay? What do we do? Yeah.
Don't you factor the numerator?
Ah, very good. No trick in you. All right, here we go. X minus what? 2?
It's minus 6 minus 8.
Oh, you guys try. Come on, you can't fool me. I'm dumb. I'm not that dumb. All right?
But don't you want to do something else?
It's negative 1.
Yep.
Can't you make it so it's the same as the denominator so you can cancel it?
No, factorizations are unique. Polynomial factorization. So this is the only factorization for this thing.
So that crosses that 2 point.
You say cross the x-axis?
Yeah.
You are correct. That's right. And it has an asymptote.
Negative 1. I mean,
Positive
1.
Positive 1.